back to my YouTube channel. So for today's video, I will do a I will discuss to you the function of TCP/IP and OSI model, and then the ARP process and the encapsulation and encapsulation. But first, I will discuss to you the TCP/IP model and OSI model. So for the TCP/IP model, we have here um, application, transport layer, internet layer, network access layer. So that we called as a TCP/IP. And then for the OSI model, we have um, 7 layer, which has a appropriate role, which is application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. So as you can see, I will discuss to you the OSI model because it has a 7 layer. So it is difficult to explain, but I will try my best to explain to you um, frequently. I will discuss to you, and I'll try my best um, to know you and the function of the per layer. So first, we have here the application layer. It has a high level of resource sharing, so it can be this is the starting point of the OSI model. So for example, it has a file. So the application layer, it is the starting point of the OSI model. So from the word application, it's sharing application to the others layer. And then the presentation layer, we have here the formatting and encoding encryption. So the the application will share the resource, and then if it will go down to the presentation layer. It can be has a data, but it can be encryption and encoding. So as we go to the session layer, it has a manage and reconnection session. So it can be after the presentation layer, it has a session layer that can be the reconnection and manage that the sender or the share file resource will reconnect to the receiver. So those uh, after those 3 layer, the data will go down and go to the transport layer. So the transport layer will go to the it can be acknowledge the data. And if the sender will send to the receiver, it can be acknowledge it. So the transport layer will go. That's the purpose of the transport layer. And then the network layer is routing and addressing layer in the network layer. And the data link layer is the one who can handle the error and control the physical link. And then the physical layer, it easy because it, as if you watch the previous chapter that I make to you, the physical layer are the ones that are called bits. So it has a ones and zeros. So that's the OSI model. Application layer, transport layer, internet, and network access. So this is the TCP IP model. So first we have here the application. So application layer, scope that from the word application, it has a DNS, DHCP, FTP, SMTP, EMAP, and HTTP. So that's are the for the application layer, and then the transport layer is has a TCP and UDP, which are commonly used for the transport. And then we have here the internet. We have here the as you can see, we have here internet. Um, for the internet is we have here the two. We have IP protocol version 4, IP protocol version 6, or what we call the IPv4, and then the IPv6. So for the network, we have a Ethernet, token ring, and then the frame relay and ATM. So that's the um, function, or um, what do we call this function, and the scope of the layer in the TCP and IP model. So I will discuss to you the encapsulation and encapsulation for the this diagram. So first we have here the applications. So first we have here the application in OSI. So for example, we will go um, I will send an email to my friend. So first I will send it for the source sharing, the application. So this is the data. So after sending the data, it will go down to the presentation, and then after the presentation, the encapsulation will go to the session. It has a data again, and then if the data will go down again and go to the transport layer will change it, and it will add a IP header, which is what we call the segment. So it will add some IP header, which is TCP and UDP layer, which is the transport layer. It has a TCP and UDP layer. So after that, the network layer, the transport layer, the segment rather, will go down to the network layer, and the transport layer has a TCP and UDP header, and then it with what we call the segment. If the transport layer will go down again to the network layer, it will add again an IP header, which is the IP header rather, and it will has a three layer. It will has a three header, which is IP header, TCP, and UDP, and then we have here the data, and then as you can see, we have here the network layer. If the network layer again will go down to the data link, it will add more IP header, not IP header. It add frame header and FCS, because it has a, as I said in the earlier, it has a data link layer. It can be an error. It can manage the error, and then after that, and the data link has a frame, UDP, IP header, uh, UDP and TCP, and then the data. So the physical, after that, the data link layer will go down to the physical layer, and the physical layer will so the physical layer, we call it bits. So all the data gathered in the data link, the frame and so on, will convert into the bits. So for example, our data will go to the 10111 and so on. So that is the uh, role of the physical layer. After the physical layer, the data bits or bits numbers will go to the NIC. So NIC go to the um, internet, and then this is um, going to the encapsulation. So the first thing we do is the encapsulation. So it can add more IP header, frames, data, and TCP and UDP. So for the encapsulation, the physical layer will go into the bits and go to the NIC, and the NIC go to the internet, and internet go to the again to the physical layer. And for the encapsulation, for the and then we have here the physical layer bits. So the bits that we the what do we call this, the encapsulation bits will form into the data link layer, which is the uh, frame. It can, but yeah, if the encapsulation will add, the encapsulation will examine if it is a match with the encapsulation. If the encapsulation examine that is a match with the data link layer, the function of data link layer will be removed. So if our data link layer has a frame and FCS, the data link layer will remove the frame and FCS, because it will go up to the network layer. And then if the network layer examine that the encapsulation has matched to the network layer, the IP header and then the IP header will be removed, because it has a examine that the network layer has matched to the encapsulation, so that the IP header will be removed, and the data will go up and go to the transport layer. And then if the data examine of the transport layer is matched with the encapsulation that we're going to do, the UDP and TCP will be removed, because it is matched to the data that will encapsulation. And then um, after removing the UDP and TCP, what do we call this? Uh, the session layer, the transport layer will the data rather will go up and go to the session layer. It has a data alone. It cannot be add more IP header frame, because it is the same on the encapsulation, because um, it has a data only. So if the session layer has a data only and go up again to the presentation layer, it has a data again, and then go up again, and the application layer will remain, and it will be received by the receiver, and that's what we call the encapsulation and the encapsulation process. So I will discuss to you the um, ARP process. So we will go to the path tracer. So as you can see, we have here the PC, 3 desktop PC and 1 switch. So I already fixed it for faster our video. So we have here the PC2, we have the IP address of 192.168.1.3 and the subnet mask here. And then we have here the IP address of PC0 is 192.168.1.4, and then the PC1 IP address is 192.168.1.2. So the ARP process is the sending of requests that has that has does not know the MAC address of the sender. So we have here we will use the broadcast here because unicast is not unicast and multicast is not very useful. So because the ARP didn't know which MAC address will send it, so we will use the broadcast for us to know where is the MAC address here. So as you can see, we will simulation mode, and then we will show all. As you can see, we have none here. So edit filter, we will use the ARP in IPv4. We will exit here, and then we will make a PDU, and the PC0 is the source destination, and then the PC2 will the destination source. So as you can see, we already put some PDU, so we will play it. So as you can see, it's successful, but it doesn't show the ARP, so I will try again. So as you can see, it has a envelope, so we will play it. It doesn't show, why? So we will delete and show all, edit filter, ARP, then exit. So we will so the PC1 is here and the PC0. So as you can see, it has a green envelope. So this the source destination is PC1 and the destination source is PC0. So I will show to you the broadcast. So we will play this. So PC1 sent to the switch, and the switch will distribute the message. So as you can see, the PC2 did not has a MAC address to respond. So as you can see in the PC0, it has a what we call the MAC address. So the PC0 is reply to the PC1. The PC2 does not have a MAC address, so that it cannot be reply to the PC1. So that's it. That's the process of ARP process. So as you can see, it's successful. So I will play it to you again. So for clarification and for more knowledgeable. So I will play it to you again. So I will delete this and I will play again. So I will show to you that PC2 has a source, and then the PC1 is the destination. So I will play this. So as you can see again, we have here PC2, the source, and the switch will distribute the message. So PC0 does not reply because PC1 has a MAC address. So PC1 will reply to the PC2, so it is successful. So as you can see, it's successful. So this is the end of the discussion of the encapsulation, OSI model, and TCP/IP model, and lastly is the ARP process. So I hope you enjoy my video and thank you for watching.